let's move to the next exercise. Now here what I am going to do is to draw a combination of squares. Let us say I have a square plate and it is required to drill a hole at the center, a square hole, okay? But the requirement is this: I want to have the sides of the hole parallel to the diagonals of the plate. This is my requirement, okay? There is a square plate. I want to punch a hole at the center. The hole is also another square, but the requirement is that the sides of the hole should be parallel to the diagonals of the plate. That is my requirement. So I am going to draw it now. Let us say the sides of the plate are 50 mm each, and this is the shape of the plate that I want. This is a regular square. And I want to punch a hole at the center. If you want the center, connect the diagonals, you get the center. The diagonals will be drawn thin. Okay. So this is a square. Let us say 50 mm side. Okay. Now I want to punch a hole at the center. Let us say 25 mm side. I want to have a square hole with 25 mm edges. So, but what do I want? I want the diagonals of the hole to be parallel to, I want the sides of the hole to be parallel to the diagonals of the plate. So from the center, I will mark 12.5 on either side. I want the edge of the hole to be 25, so from this center I mark 12.5. Now align your rotor scale with one of the diagonals like this, then move it up till you come to that point. Once you come to that point, you draw a line parallel to the diagonal. Similarly, moving down, you can draw this line. Moving other way, you can draw this line and this line. So basically these four lines are obtained using your rotor scale. Okay, they are drawn parallel to the diagonals and the side of the hole is 25. Normally it's a practice to show the dimension for a hole inside. Okay, so when I show the dimension inside like this, it is understood that it is a hole. Square 25. So you can see here the diagonals of the sides of the hole are parallel to the diagonals of the plate. The outer one is the plate. Okay, you have punched a hole at the center. So this is a combination of squares. Now the next exercise. Suppose I want to have a reverse combination of this. Reverse combination in the sense, I want to have a plate of this shape and a hole of this shape. So reverse combination. When you use your software, you will not draw it. You will just rotate the sketch by 45 degrees. You get the required position. Okay. The rotation angle will be 45. You will just move it here. Then taking this point as center of the rotation, you will rotate it by 45 degrees. You get what is required. But let us see how to do it manually here. Now let us draw the plate first. The edges should be inclined at 45 degrees. So I am drawing an edge of 50 with 45 degree, another edge with 50. So each of these angles are 45, and I am completing the plate using a scale and a protractor. 90 degrees. This is also drawn at 90 degrees. Okay. Now these are the diagonals. This is the center. Let me dimension this. This is square 50. Now you have to punch the hole. From the center, you will mark 12.5 on either side. You will mark it on both the diagonals and then complete this. This side is 25. So you will write inside square 25. So this is the other combination. Now the next sketch is a rectangle. Rectangle, you know how to make a rectangle. Let us say the dimensions are 50 and 30. The length is 50 and the width is 30. When you mark the when you write the dimension, make sure it is written like this. And you can draw the diagonals to identify the center. Make sure the diagonals are made light. This is the center. Only the boundary should be dark, whereas the inner diagonals have to be made light. The dimension lines, of course, are light. The extension lines, of course, are also light. Now, rotating this by 45 degrees, you can get the next position of the rectangle. So, in that case, both the length and breadth of the rectangle will be inclined at 45 degrees to each other. So, if you imagine this to be the center of rotation, how do you get it? This is the center of rotation. First, you will draw the width of the rectangle at 45 degrees equal to 30 mm. This is the width. This is inclined at 45 degrees. So you are drawing this using a protractor and also a scale and pencil. Now again you use a protractor, mark 90 degrees here. Okay, this length is 50. This is 45. This is also 45. This length is 30 mm. This length is 50. And then you can complete the rectangle. From here again you can use protractor, mark 90 degrees. From here also protractor, mark 90 degrees and complete the rectangle. When you draw the diagonals, they will be inclined like this. This is the center. So, mark the dimensions. This is 50 and this is 30. So when you complete the sketch, only the boundary of the rectangle should be made dark. Okay, the diagonals should be made light. Of course, the dimension lines also will be light. Even the arrowheads, you are shading the arrowheads inside, the shading also should be light. Okay. The next exercise will be a pentagon. Okay, let us see how to draw a pentagon. We started with a triangle, a three-sided polygon, then a square and rectangle. Now it is a pentagon. What is a pentagon? It's a five-sided polygon and all the five sides are equal. Now what you should know here is, for a pentagon, the included angle between any two adjacent sides is 108 degrees. This knowledge you must have. I repeat again, the included angle between any two adjacent sides in a pentagon is 108 degrees. Let us see how to draw it. let us say this is one of the edges of the pentagon, the vertical line. Let us say once again it is 40 mm in length. So I have drawn the extension lines and this is the dimension line. This is 40. With this as one of the edges, I want to complete the pentagon. As I already said, the included angle has to be 108 degrees. Now using your scale and pencil, you can just draw these two lines which are horizontal. In other words, they are perpendicular to this. So what angle they are making here? 90. Each is making 90. But what is the angle that is required? 108. So if you put your protractor, you have to make an angle of 18 degrees with the horizontal. 90 plus 18 will be 108. Or if you can make an angle of 108 with reference to this line also. With reference to this line, the angle should be 108, or with reference to horizontal, the angle is 18 degrees. So let us say this is the line. So this angle is 18 degrees. In other words, the total angle is 108 degrees. Whatever you have done there should be done here also at the bottom. With reference to horizontal, you are marking an angle of 18 degrees. So this angle is also 108. So far you have used a scale, pencil and protractor to get these three lines. Now once you get these 2 points, of course each of these edges are 40 mm each. This also should be 40, this is also 40. Once you get these 2 points, you can now make use of your compass, drawing compass. Okay. Now you are going to draw 2 arcs with 40 mm radius. Once using this point as center, radius as 40, draw an arc. Now this is the center, again radius is 40, cut that arc. Wherever they intersect you get a point, then you can connect these edges using scale. This angle will be automatically 108 degrees. This is how you can construct a pentagon using, what are the instruments used? Scale, pencil, protractor and compass. All the 4 you have used. So this is, here also you just have to show the dimension for one edge, preferably the vertical edge, we show the dimension. Now I will get the same pentagon in another position, where this edge, see for example if you take this, I started with the left side and proceeded to the right. I can do the reverse of this. I start with a vertical edge on the right side and proceed to the left. Okay. So I am starting with an edge here which is vertical. This is once again 40 mm. So I am dimensioning this. Don't forget to do the dimensioning, it's very important. Okay. So as soon as you draw the edge, go to the command smart dimension and dimension it, because once you complete the sketch you may forget to dimension. That should not happen. Now adopt the same procedure whatever I have done here. First you can draw 2 perpendiculars. These perpendiculars make an angle of 90 degrees with the vertical. I need an extra 18 degrees, okay, to draw the adjacent sides of the pentagon. So here you will make 18 degrees, draw another line. This is 18 degrees. Similarly here, 18 degrees. Now measure this to be 40. This is also 40. Okay. Now you are going to use a compass and draw 2 arcs. This has center 40 mm radius, you draw an arc. This has center 40 mm radius, another arc. You get this point, then connect the points using a scale. Okay. This will also be 108. Anywhere you measure the angle, it should be 108. Now, when you are using the software, if you take this polygon, this pentagon, this is just a mirror image of this. If you consider this to be an object, this is just a mirror image of this. So, you have a command called mirror in your software. So, you can draw a line, vertical line, and you can use this as mirror. So, draw this line, go to mirror command, okay, and select multiple objects, click on this mirror, this will automatically come. Okay, so you are drawing this pentagon using a command called mirror when you execute this exercise using your software. Now let us take up another position for the same pentagon. Let us say in the next position, I will start with a horizontal side. I will start with the horizontal side at the top and proceed down. Let us say this is one of the edges of the pentagon. This dimension is 40. Now I am proceeding down to complete the pentagon. So these are the two verticals. Now I need an extra 18 degrees. So with this, with reference to this edge, I mark an angle of 18 degrees. The length is again 40. Similarly here. So this is 18 degrees. This is also 18 degrees. Now you have these 2 points with you. You can make use of compass. Draw 2 arcs here using 40 mm radius and then connect. Okay. So this angle will be 108. It's quite easy. The same procedure. Okay. What is important is where you are starting and what is the position of that edge. Now, let us see how to find the center for a pentagon. If it is a square, how do you find the center? Just connect the diagonals, the intersection will give you center. Similarly, rectangle. But when it is a pentagon, how to find the center? Let us say you are asked to punch a hole at the center for the pentagonal plate. So how do? You need to find the center. This is how you have to find the center in a pentagon. You need to draw perpendicular bisectors for any 2 edges. For example, if I select this edge, if I have to draw a perpendicular bisector, what I can do is go to the opposite corner and just draw a perpendicular from the opposite corner. When you draw a perpendicular, it will divide it into 2 equal parts. So it becomes a perpendicular bisector for that edge. So what did you do? From this is the edge, this is the opposite corner. From the opposite corner, you have drawn a perpendicular to this line. That is one of its perpendicular bisectors. Similarly, you can take any other edge. For example, if I take this edge, this is the opposite corner. From the opposite corner, draw a line perpendicular to the opposite edge. So this angle should be 90. This is also 90. So these 2 lines are perpendicular bisectors for this edge and this edge. Wherever they intersect, you get the center. So in a pentagon, the center is the perpendicular bisectors of any 2 edges. The intersection of the perpendicular bisectors of any 2 edges. Now let us say I want to punch a hole there, a circular hole. Let us say the diameter of the hole is say 20 mm. Okay. So you take 10 mm radius and draw a circle here with this as center. The diameter is 20. As I said already, for a hole the dimension is shown inside. So I am showing the dimension here. The diameter is represented by phi. So we are using a prefix phi here. I will write phi 20. That means the diameter of the hole is 20 mm. The next exercise is to have a mirror image of this. Okay. This time the mirror will be a horizontal line. Okay. So manually how do you do it? You start with a horizontal side at the bottom and you proceed to the top. So I am starting with a horizontal side here. Let us say the side is 40 mm. This time you are proceeding up. So these are the verticals. With the vertical, make an angle of 18 degrees. This is 18 degrees. This is also 18 degrees. Once you get these 2 points, you are going to use a compass to draw 2 arcs with 40 mm radius and then connect. So this is a mirror image of this. Of course, without the hole I made it here. So we have drawn 4 pentagons so far, and then let us say, let me tell you what is the angle here. Can you tell me what is this angle? Inclination of each of those edges. The total angle is 180, out of which 180 is gone. So you are left with 72. So each of these will be 36 degrees. Okay. So if you are required to draw a pentagon with an edge making an angle of 36, you can do this. Okay. How do you do it? You start by drawing an edge at the top or an edge at the bottom. Okay. The 2 edges will be inclined at 36 degrees with the horizontal. Let us say that is a specified angle to you. You are asked to construct a pentagon with one of the edges inclined at, let us say, 30 degrees. How to do that? You want to make a pentagon with one of the edges inclined at 30 degrees to horizontal. Quite simple. Start by drawing that edge first. Let us say it is inclined at 30 degrees. Now, using this as one of the edges, you must complete your pentagon. Let me dimension this first. This is 40 mm. Now you are going to make 2 perpendiculars to this line. These are inclined at 90 degrees. Now you are going to take 18 degrees extra outward using your protractor. This is 18 degrees. This is also 18 degrees. Once you get these 2 points, you are going to complete the pentagon by drawing 2 arcs using a compass. With this as center, 40 mm radius, you draw an arc. This as center, 40 mm radius, another arc. Wherever the arcs intersect, you get the point, complete the pentagon by connecting the lines. Okay. This angle will be 108 degrees. So this is about a pentagon. What is that you should know is the inclination between any 2 adjacent sides in a pentagon is 108 degrees. When you move to further chapters like projection of planes and projection of solids, you have an option in the software called n-sided polygon. We don't use that option when you do in the geometry constructions. In the n-sided polygon, you can choose what is the edge of the polygon that is required. Let us say 40 mm as in this case, and you can choose the number of sides that you want. For a pentagon it is 5. So as soon as you select the edge as 40 mm and number of sides as 5, it will automatically give you the pentagon. Okay, so that is called as n-sided polygon. We do it when you move to further chapters like projection of planes and solids. But in geometry constructions, you should know how to do it. Okay, so we don't use the n-sided polygon command in this drawing when you use your software. Okay, next we will continue with hexagon. That will be the last polygon. Okay students, let us move to hexagon now. Hexagon, as you know, it is a 6-sided polygon. All the edges should be equal. In a hexagon, the angle between any two adjacent sides is 120 degrees. 120 degrees. Now, how do you draw a hexagon? It's like this. To draw a hexagon, we start by drawing a circle first for construction. So the circle is drawn for construction's sake. It should be drawn thin. The side of the hexagon is equal to the radius of circle. This is important. Okay. If you want to draw a hexagon of 40 mm side, you should draw a circle of 40 mm radius. Okay. So let me start by drawing a circle first here with 40 mm radius. So you use your compass and draw this circle. Let me connect the vertical diameter of this circle. So this is done for the construction. So the circle has to be thin. This diameter of the circle is also thin. You are using thin lines. Now take your compass. Select 40 mm radius. Take this point as center. Okay. Cut an arc on both sides equal to 40 mm. You are using 40 mm radius. Just draw an arc on either side of the center. Similarly, take this point as center. Again 40 mm radius. Draw an arc here and also here. So how many points you have on the periphery? 1, 2, 3, 4, 5 and 6. Connect all the 6 points using straight lines. These lines you are using dark lines. This is a hexagon. Okay. The included angle between any two adjacent sides will be 120. Show the dimension preferably for the vertical edge. This is 40. So when you complete the hexagon, the circle, the vertical diameter and the arcs, whatever you have drawn, should appear faint. Okay, I want only the 6 edges to be shown dark, or they should appear dominating on your sketch. Okay, this is one of the positions of a hexagon. Now can you tell me what is the angle, this angle? As you know, this angle is 120, the included angle. Because the total angle is 180, 180 minus 120 is 60, so each of these should be 30. So if you are required to draw a hexagon with one of the edges inclined at 30 degrees to horizontal you can go for this. If the inclination required is 30, okay, you draw a circle first, then connect the vertical diameter and then proceed. The method what I have mentioned now. Suppose you want this angle to be 60, okay, then what do? I want a hexagon with one of the edges inclined at 60 degrees to horizontal. How do you do that? Start by drawing a circle first. The radius of the circle is equal to the side of the hexagon. This time I will start by drawing the horizontal diameter. Okay. Now proceed in the same manner like what I did in the last problem. Select this point, take a compass, take this point as center, 40 mm radius, draw an arc on either side. Similarly, using this as center, 40 mm radius, you will draw two arcs on either side. Now there are 6 points on the circle. You can connect them using straight lines. This is also a hexagon. It's in a different position. The angle between any two adjacent sides is 120. So what will be this angle? This will be 60. So one of the edges is making an angle of 60 degree with the horizontal in this case. So when the inclination required is 60 degrees, you are starting by drawing the horizontal diameter of the circle. Show the dimension preferably for the horizontal edge. Let us say 40. No prefix here. We are using prefix only for the square. When you do the dimensioning, only for the square prefix is used. You don't use it for a pentagon or a hexagon or a rectangle. So here one edge is inclined at 30, here an edge is inclined at 60. Suppose if I want it at some particular angle, you are required to draw a hexagon with an edge inclined at, let us say, 45 degrees. How to do that? These are quite simple, okay? Only thing is, you must make sure the construction lines are made light. Now, let us come to the last exercise of this drawing number 1. I want to draw a hexagon with one of the edges inclined at 45 degrees to horizontal. Can you tell me how is it like that? How is it made? It is just that you have to make the diameter of the circle inclined at 45. That's all. Okay. I will show it. I will draw it and show to you here. Okay, I will draw it here. Again, I am drawing a circle, 40 mm radius. This is horizontal, this is vertical. Now I am going to draw a line inclined at 45 degrees. So this line is inclined at 45. Because I want one of the edges of the hexagon to be inclined at 45. Now these two are the centers for you to draw the arcs. Okay. Take this point as center, draw an arc with 40 mm radius here and another arc here. Similarly here, the radius is 45. So mark all the 6 points on the circle and then connect them. So this edge will be inclined at 45 degrees to horizontal. These two edges will be parallel to this diameter. Okay. Finding the center is quite easy in a hexagon. If you want to find the center, you just have to connect the diagonals, the opposite corners. That's the center. Finding the center in a hexagon is quite easy. Okay. That's all. That completes the drawing number 1. So we started with a line, dividing a line into number of equal parts. You have learned how to do it. We have done this exercise because it is used in one of your chapters called development of surfaces. There that exercise can be made use of. Then all these polygons you will be using when you move on to planes and solids, projection of planes and projection of solids. Okay. So there I will not be telling you how to draw a pentagon, how to draw a hexagon. Straight away I will ask you to draw a pentagon. You should be able to do that. Okay. That's why this exercise is done, though it is not included in the syllabus. So all these exercises are covered under drawing number 1. So this video will be uploaded to the YouTube, and the YouTube link will be sent to you so that you will have access to that. And normally I will give 1 week time for you to submit the assignment. Okay. If you maybe you may not be able to include all these in one sketch, one page. So number of pages, you have to take the photo of that and you can send me, or you can upload it to the Google Classroom. The platform, as I already mentioned, we are going to use Google Classroom. Okay. And for the regular classes, whatever is done here, this is to be done using your instruments. It is a manual sketch. So this is the assignment that you have to complete. Whereas using the software, how to make these things will be taught to you in the regular class. You will be given a time slot as per your timetable. So during that time slot, I will be teaching you how to do the drafting for the same. Okay. So that completes your drawing number 1, basic geometry constructions. The next video will be very, very important, which will give you the basics of orthographic projection. Okay. Before we move on to projection of points, I will teach you what is orthographic projection, which is the basic class or very important class. So when we normally conduct the classes, I used to tell my students, as soon as this class is over, the next class is very, very important. And because it is going to be recorded anyway, okay, you can use it any time that is required. This recording will be sent to you. Okay, but remember, that's a very, very important class. You can watch it any number of times. Okay, students, see you in the next class.